All right, guys, so before we get started on the notes today, are there any questions on any of the homework assignments? I think you said you're finished with it. Yeah, I'll go on and take it. Thank you. All right. Let me do that. Yep. So this is where we got to yesterday, solving quadratic equations. Now, throughout the course of kind of just Algebra 2, as all of y'all at this point have taken it, y'all have come to realize there's many different ways we can solve a quadratic equation. One of the first ways that y'all probably went over solving quadratic equations is by graphing. Because if we graph the quadratic equation and the points at which it crosses the x-axis would be the solutions. The second way that we normally go over it is by factoring. Because if we're able to factor the quadratic function, then we can use the zero product property, because two things that multiply together to give us 0 would help us be able to solve this. And then there's kind of some special factors, the difference of perfect squares, factoring by grouping. We can do those for higher degree functions. Normally after this we have completing the square. Is normally about the third way that at least I go, and kind of the normal order would be completing the square. And lastly, we have the quadratic formula. F-O-R-M-U-L-A. And these are kind of the main ways that we go about solving quadratics. Now, for most of these, almost all of these, except for completing the square, whenever we solve a quadratic, we need everything on the same side. So if we're going to solve this by any of these here, except for completing the square, we would need this equal to 0. So the first thing we can do is, well, subtract 3 from both sides to get it equal to 0. Because we'll still have 2x squared plus 9x plus 4 is equal to 0. Now at this point here, we can decide if we want to factor it, graph it, use the quadratic formula, because any one of these could possibly work. The only two that work for sure every single time are completing the square and the quadratic formula. Those are the only two that work every time. Now for this one here, we can try factoring first to see if this would work. And if we're going to factor it, we first see if there's a greatest common factor between each of these terms. Well, there is one between 2x squared and 4, but 9x does not. So we can't pull out a greatest common factor. So we can use our two sets of parentheses with 3 spaces. Now when we look at the signs, we always look at the third term, which in this case is positive 4. And if the third term is positive, the signs are the same and they'll match the middle term. So here, they're both going to be the same, and they're actually both positive. Now the next thing we'll look at is the factors of the first and third term. First and third term. Now the first term is 2x squared, and the third term is 4. Now if we look at the factors of 2x squared, bless you. Well, the factors of x squared, the only set we have is x or x. That's the only way we can multiply two terms to get x squared. And the factors of 2 are, well, 1 and 2. So we can just pick one to put 2 in. Because again, at the very end of this, we can check it to make sure we did get the correct factors. Now the next one we need to look at is 4. Now 4 does have more than one set of factors because we do have 1 and 4 or 2 and 2. Which one do we want to use first? Or try first? Well, I'm going to put this up here briefly because we could do 2 and 2. It'll let me. But this one won't work. Because if we look at the first set of parentheses, we have 2x plus 2, yes? Is there a greatest common factor between those two terms? Yes. So since there's a greatest common factor here, we can pull it out front, yes? But one big thing with factoring, if there wasn't one to begin with, so 2x squared plus 9x plus 4, if there's not a greatest common factor there, there can't be one in either one of these here. Now, if there is one in one of these here, and we look back to see, okay, is 2 a common factor to begin with? Okay, it might be, and we can pull it out and then go from there. But here, we see that 2, 9, and 4, there's not one. So what that tells us is that this 2 and 2 won't work, because even if we flip it, we'll still have a greatest common factor of 2. So we're left with 1 and 4, which means this has to be 1, this has to be 4. Because if we did it the other way, well, 2x and 4 would still have a greatest common factor. Now we can check this here. Highlighter. Because 2x times 4 is going to be positive 8x. 1 times x is going to be plus x. And 8x plus x is 9x, positive 9x. Is that the middle term we wanted? Yes. We don't have to check the first two because 2x times x will still give us 2x squared. 1 times 4 will still give us the plus 4. So we have everything we need, and these are our two factors. Any questions on this so far? Now we do have two things multiplied together. So if we multiply two things together and get 0, one of them has to be 0, which tells us that either 2x plus 1 is equal to 0, or x plus 4 is 0. Now we just need to solve for x. As for the first one here, we can subtract 1 from both sides, telling us 2x is equal to -1. Divide both sides by 2, telling us that x is equal to -1/2. And there's one of our solutions. Now for the other one, we can subtract 4 from both sides. Telling us x is equal to -4. That's it. Questions on this so far? Kind of remember this, some of this coming back. All right, so the next one we have is 2x squared minus 3x plus 1 equals 6. We can do this one a little bit differently. We can do this by the quadratic formula this time. And if we're doing this by the quadratic formula, well, again, we need this to equal 0. So we can subtract 6 from both sides. Telling us that we have 2x squared minus 3x minus 5 is equal to 0. Now again, the quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this here is just the quadratic formula. And just as a reminder, because the general form of any quadratic is ax squared plus bx plus c. So we're plugging these terms in, we're plugging their corresponding values for a, b, and c. So in this case, the two a's are going to be in place of 2. 2 is going to take their place. B is going to be negative 3, and C is negative 5. And we can plug those in respectively. So the first thing we have is negative B. So we have negative, negative 3. Plus or minus the square root of negative 3 squared minus 4. A is 2. C is negative 5 all over 2a, or 2 times 2. And we have this here. Now there's a few things we could have done and simplified as we plugged it in. Get a highlighter out. One of them was this here, negative, negative 3. We could have just written it as positive 3, because we know a negative and a negative will make a positive. The other place I will simplify, when I just plug it in, is the denominator here, 2 times 2, which is 4. Multiplying by 2 is not too bad, but I don't normally do more than this all at once, because again, that's a lot of calculations to do at the same time. And the more that we try to do in one step increases the likelihood that we'll make a mistake somewhere. So, as we were just saying, this here, we really have positive 3 and 4. Now, when I work problems like this here, the next thing I would do is calculate what's inside the radical. And we could do this in a calculator, because again, I'm not restricting the use of calculators. The next thing I would do is I would type this into the calculator to see what we get. I don't use the square root because there's a chance that it could be irrational. The square root doesn't fully simplify. So we could do this here in the calculator, or we can do it by hand. Either one is fine, because if I do this by hand, negative 3 squared will give us a positive 9. Negative 4 times 2 is negative 8, and negative 8 times positive 5 is going to be plus 40. And 40 plus 9 is 49. Now, luckily for us, that does simplify, because the square root of 49 is 7. Now, using the quadratic formula and it get to this point here, if this radical did not simplify, if it did not simplify all the way down, we would leave it in radical form and be done at this point. But since it did simplify, and we're able to add and subtract the numerators, we're going to need to add and subtract the numerators. Because if I can add, well, here we can definitely add 3, and we can add 3 and 7, and we can definitely subtract 3 and 7, so we need to find out what the two solutions are. Because what we're saying is that we have x is equal to 3 plus 7 over 4. And we also have that x is equal to 3 minus 7 over 4. And again, at this point here, if you wanted to type this into the calculator, go for it. So you can plug in the calculator 3 plus 7 divided by 4, hit enter, and it'll tell you that it is 5/2. Seems like a weird jump because 3 plus 7 is not 5. 3 plus 7 is actually 10 over 4. 10 and 4 do have a common factor of 2, which will reduce it to 5/2. Now again, you could do the same thing with the other one, 3 minus 7 divided by 4, which should give you -1, because 3 minus 7 is -4, divided by 4 is -1. So these here would be our two solutions. Any questions over any of this here? All right, let's look at another one. 6x squared minus 3x. Now, we can use the quadratic formula for this here, and it would work out pretty nicely. But the value of c in this case would be what? Not quite. It would be 1, because c would be our constant term. And if we don't have a constant term, it's understood to be not 1, but 0. So we could use it and just plug in 0 for c. Yes? But whenever we don't have a constant term, what I fall back to is factoring. Because is there a greatest common factor between 6x squared and -3x, or 3x? Well, we do have one for sure, and it is x, yes? I'm going to write this over here as solutions. I haven't done that on the previous ones, but I'm doing this because I know what one solution is to begin with. And that's x is going to be 0. Because again, we're looking for what? When we look for solutions, we're looking for what value of x is going to make this thing be 0. Yes? Do we have, so it is already equal to 0. Yes? If it's already equal to 0 and I don't have a single constant term, x equals 0 is always going to be a solution. X equals 0 is always going to be a solution. Because if we look back at the previous one, this is 2x squared minus 3x minus 5 is what we got after we got it equal to 0, yes? If I plug 0 in, let me get a highlighter. Well, this whole thing would become 0, yes? But then I'm left over with what? -5. -5 does not equal 0. Okay, so that doesn't work. Now, if we look at this one here, we don't have that constant term, do we? So if I plug 0 in, well, this term would become 0, yes? Because anything times 0 is 0. This term here would become 0, because every spot that has an x and anything multiplied in front of it would automatically become 0, yes? Do we have anything left over? Well, no. So these here I always like because, well, no matter what happens, I do know one solution every single time. It's going to be 0. And part of the reason we get that is because, again, we can factor out, apparently I'm just going to write in highlighter, I can factor a 3x out because 6 and 3 do have a common factor of 3. But the biggest thing is that x squared and x have a common factor of x. And if I factor that out, pull the eraser up. If I factor those out, if I factor 3 out of 6, I'm left with 2 and then x. minus, because we didn't change any of the signs, we didn't factor out a negative, so it's still going to be minus. If I factor a 3x out of 3x, I'm left with 1 is equal to 0. Now again, the product property, the zero product property states that any two things multiplied together to equal 0 means one of them has to be 0. So we're saying that 3 times x is 0, or that 2x minus 1 is equal to 0, yes? So there's different ways we can, the one main way probably that y'all would go about solving 3x equals 0 is divide both sides by 3 and seeing that x is 0, yes? But how did we get to these two equations? We said that any two things multiplied together to equal 0 means one of them has to be 0, yes? Well, 3x equals 0. We have 3 times x is equal to 0. By that same property, I have two things multiplied together to equal 0, so one of them has to be 0, yes? Is there any way I can turn a 3 to a 0? Well, no, it's 3. We can't change it. Well, the only thing I can change is the x, so that means x here has to be 0. Well, we knew that outcome from the beginning. So we get one solution already. Now we just need to solve for the other one. Here we can add 1 to both sides, telling us that 2x is equal to 1. And then lastly, we can divide both sides by 2, telling us x is equal to 1/2. So our two solutions for this here are 0 and 1/2. Questions on this here? So again, we're looking over many different quadratics or different types that we've covered over the years, and that y'all probably covered also. So if we don't have a constant term, we know that one of them is going to be 0. We can factor the x out and move on from there. Now here, realistically, we have the quadratic term, the 4x squared. We don't have a middle term. We don't have that linear term, just the x. But we do have a constant. Now we could move the 12 back over, do completing the square or quadratic formula, or factoring to solve it. But on these here, I like the square root method the best. And what the square root method states is whenever we are dealing with ax squared minus c is equal to 0, we get the x squared term by itself, or whatever the parentheses squared is by itself, and then square root both sides. So for this here, we already have the constant term over. We just need to divide both sides by, bless you, 4. Because what that tells us is that x squared is equal to 3. X squared is equal to 3. And at this point here, we can square root both sides. And the square root of x squared is x. Is equal to, well, square root of 3 doesn't simplify. We can't find a whole number or a natural number or an integer that when multiplied by itself gives us 3. But the only other thing we need to do is add the plus or minus. Because whenever we square root both sides, we're trying to see what number times itself gives us 3. Because positive square root of 3 times positive square root of 3 would give us 3. Negative square root of 3 and negative square root of 3. The negative would multiply together to give us positive. And the square root of 3 times square root of 3 would still give us back to 3. So we have this here. Questions on this here? So normally whenever I see an x squared term and then the constant term, I'll move everything over and use the square root method. But again, quadratic formula would work just fine with this here. Any questions on this so far? Interestingly enough, this here is another kind of square root method model, because we could use the quadratic formula, but to use it, we would have to multiply x minus 3 by itself, and then move the 7 over and get everything in the form of ax squared minus bx, or ax squared plus bx plus c is equal to 0 to be able to use it. But here, we do have a set of parentheses that's already squared, yes? And it's not equal to 0. If it was equal to 0, it would be very nice, because then it's just saying that x minus 3 times x minus 3 is 0. So one of them has to be 0. But here, let's see what happens if I square root both sides. Well, here the square root and square will cancel out. They will simplify out, leaving us with x minus 3 is equal to plus or minus the square root of 7. And that's why this is nice, because now that exponent's gone, and we do have, are pretty much one step away from the solution. It's a little bit easier to work with. The only thing we have left to do is to add 3 to both sides. So this x is equal to 3 plus or minus the square root of 7. And that's going to be the final answer. That's as far as we can take it. Questions on this here? Do we understand how this works? Yes. Because I believe that y'all have gone over some of these, especially in Algebra 2, how the square root method works, why we would use it for this here, and not use another method. Yes? Okay. So this one here, we'll look at one example of completing the square, because again, completing the square will come up again eventually, especially when we talk about conic sections or hyperbolas, parabolas, not so much parabolas, but circles and ellipses and these here, because they will give it to us in a non-standard form. And for, let's see here, an ellipse, the standard form, or one of them, is this here. This is the standard form. But they won't give it to us in this form. Most likely they'll give it to us in this form here. So we'll have to use completing the square to work it back out so that we get it in the form we want. So it's good to at least be familiar with completing the square. But again, when we go over this here later in the semester, when I mean later in the semester, I mean we're talking into November, December, last chapter. It's good to know. And it's probably been a while since you did completing the square. Most of the time when we do completing the square, y'all do it once or twice. You get to see it. You do a homework assignment over it, and then most of y'all put it away. Like that Christmas gift that you get from a relative that you can't get rid of because there's some sentimental value in it, and you have to pull it out every year. So that's because you guys have at least seen it once. With completing the square works very nice if A, the term in front of x squared is 1. If not, it gets a little funky really quick. But luckily here, A is 1. Because our first main step is A equal to 1? If not, make it so. Essentially, we have to divide the entire equation by whatever that number is. Step 2. Remove the constant term. Now this has changed because for those of you who had me last year for Algebra 2 or had me for Algebra 2, this is a little bit different wording because the way I worded it for Algebra 2 is that we move the constant term to the other side of the equation. I'm using this here because once we get into a lot of the quadratics, we'll deal with this constant term differently. But in this case, we can move it to the other side. And we can move the constant term to the other side in most of them. Because what that leaves us with is x squared plus 2x plus blank equals 6 plus blank. Okay, I got ahead of myself. This is the step I was thinking of. As we're just removing the constant term. Step 3, find C, because we want to find our new constant term. Because what we're trying to do in completing the square is to rewrite this quadratic as a set of parentheses squared. That's the whole goal, essentially getting it to a point where we can use the square root method to solve for quadratics. For the ellipses and parabolas and circles, what we're trying to do is get it back into a set of parentheses squared, because that's the form that it wants for the general equation. Now, C, in our case, is equal to b over 2 squared. B over 2 squared. Well, if we look at this here, what's the value of b? 2. So C is equal to 2 over 2 squared. Well, 2 divided by 2 is 1, and 1 squared is 1. So what that tells us, this here is a perfect square trinomial that we can rewrite it as a set of parentheses squared. It's the same thing multiplied by itself. One thing we know for sure is that it will have an x. Now the other term that goes in here works out to be whatever the term is before we squared it with its sign. So we know that this other term is going to be 1. But the sign, since it's positive, this here is going to be a plus. Because if it had been -1 before we squared it, it would have been -1. And it works out that way every single time. But what did I do in the step above? I added 1 to the left-hand side, yes? If I do something to one side, I have to do it to the other. Now, when I said there's something different, this is the step I was thinking of, not the one before. When we start working with this in some of the ellipses and parabolas, we'll have to do it a little bit differently. We'll have to put it in a set of parentheses, the plus and minus. Because most of the ones we'll deal with parentheses, the value of a won't be 1, and we're not going to divide it out. We'll actually factor it out. So it'll be a little bit different there, and that'll cause a difference. But, as I said, we're still a little ways out. Well, we could have added those together in the step above. So really what we have is that x plus 1 squared is equal to 7. Because 6 plus 1 is 7. Now at this point here, it's the same as the last one we did. We can square root both sides, telling us that x plus 1 is equal to plus or minus the square root of 7. And then last but not least, we would Subtract 1, telling us x is equal to -1 plus or minus the square root of 7, and that would be our solution. Any questions over this here? So this kind of hopefully came back to y'all, especially how we do this here. Because once we find C, we're pretty much good to go. The only other step for these here is to solve and we're done. But again, any problem that we could solve using completing the square, we can actually also do with the quadratic formula. We could have solved this with the quadratic formula and gotten the same answer. Any other questions over this here? Do we need to see another example with completing the square? Because I'm not going to, there's going to be a few here and there. I don't think I'm going to restrict you too much on these here. So, where we're at. Okay. If we feel comfortable with completing the square, we can move on to this one here. This one here will be the last problem we work today, and then obviously we'll have to finish these tomorrow. So we have 3x to the fourth is equal to 48x squared. Does anybody have a guess at what one of the solutions is going to be? Zero, yes. And I'll match you and say another 0. Now, there's a reason that this does work the way that it does. And there is a reason behind me putting 2 zeros. Because if we look at the variables on either one, what is the smallest power that we have for x? 2, yes? So that means they should have at least 2 in common that we could factor out, which gives me 2 zeros. But let's work through and see how that works. Because again, the first thing we can do is subtract 48x squared over. I do this here because I like having the biggest exponent, not the biggest exponent, the variable with the biggest exponent positive. That's just something I like doing and keeping in form, or in that way. So let's erase that. So we'd have 3x to the fourth minus 48x squared is equal to 0. Now, it is possible to use the quadratic formula on this, but we would have to most likely use U substitution and go from there. But there is a greatest common factor between these two terms. And one of them is x squared. Will 3 go into both 3 and 48? So 48, we can figure it out a little bit easier than trying to divide it by 3. We can add the two terms together. So 4 plus 8 is 12. Is 12 divisible by 3? So 48 is as well. Because our 3 property with division, a number is divisible by 3 if the sum of its terms is also. So it tells us that 3 is also a greatest common factor. And if we factor 3 out, 3x squared out of 3x to the fourth, we're left with x squared minus 3 divides into 48 16 times. Let's see here. Nope. Yes. 16. Yeah, I was thinking of 4 there for a second. But yes, it's 16. And the x squared factors out completely. Now, by the zero product property, we're saying that 3x squared is equal to 0. And x squared minus 16 is equal to 0. Now, for the first one here, we're saying x squared essentially is 0. So x is 0 with a multiplicity of 2, because we could take the square root of both sides, which would tell us that we have plus or minus the square root of 0 which is just 0. And we get this here. Now for the other side, since we don't have a middle term, since we don't have a term with x, we can use the square root method. We can add 16 to both sides, telling us that x squared is equal to 16. Square root both sides, telling us x is equal to plus or minus 4. And that would be it. And that's where we'll stop for today. Now, this one here is also graphable. If you wanted to graph it, you could. And what you would get is this function here, where it's crossing at -4, 0, and 4. Now, I know that this is the graph because anytime we have a single 0 show up or a solution only showing up once, it's going to cross. Anytime we have a doubled 0, it's not going to cross. It'll touch that point and go back down. And then we have again. So this would be the overall function. But again, I'm not expecting y'all to know that because, again, knowing these functions and how they look at is helpful, but not necessary.